John, I'm going to turn it over to you, start going through these slides so you can start giving the update on where we are with the technology.
Great, thanks. Yeah, just a quick overview is our team used to work at Sandia National Labs quite a while ago, about 30 years ago, optimizing fiber optic lasers. And we have created a new patented chip which takes that kind of laser and adds many lasers to it, sums them on the chip, and allows us to get enough high optical power to do wireless communications. The tests show that we have yet to find out how high of a power we can go, but we've actually got watts of power, which is very unusual for a laser chip that is able to send 10 gigabits per second of data over distance. The cool things about this chip is that it has high bandwidth, high power. We can control divergence angles, and it has incredibly low C-swap, which is cost, size, weight, and power. It's capable of radiation hardness for space, and we are in a NSF grant that is showing, demonstrating non-mechanical beam steering. We're going into phase 2 after successfully demonstrating that in phase 1. Let's go to the next slide, please. Its bottom line is it is a tiny chip that basically costs us $1 in production to fabricate in that one chip. The one that we're using right now is modeled for a 2-kilometer link, and we have a DoD project making using that in a network configuration. But you can see this chip right here down in the bottom part of the screen is got a lot of lasers on one side and lenses on the other, and those lenses are offset in a way that we can have it sums all of the beams together into a single uniform spot. Let's go to the next slide, please. And I'm not going to go into the data, but it's really cool because it's not a coherent source. It's actually a low coherent source, which helps with scintillation issues that normal lasers have in going through the atmosphere. We've also seen that we can virtually get as much power as we want on these chips. Let's go to the next slide. Just to mention, these are world record speeds and powers for a semiconductor device with this low of a C-swap. The chip that we're using right there on your finger has 19 lasers on it, and it's able to get 0.4 watts of power. We only need 0.2 watts to get the 2-kilometer distance. Our system that we built with this has gone between 2 buildings at 10 gigabits per second, and we're on our 4th prototype. And so I'm going to turn this over to Mathis to tell you more about our business capability. We've got 8 patents issued now, and a number of PCTs across the world to be able to patent this in different countries.
I think just this slide before I step in, this is a very relevant slide in terms of where we're going with the NSF grant that you might want to touch on quickly.
Yeah, so the NSF proposal is to basically non-mechanically direct the beams like a phased array for a 5-millimeter. I mean, for a 5G signal. The 5G signals basically direct their beams with a phased array. We are showing we can do it with different chips, basically sequencing through the chips, so we don't really need the phased array. This basically puts us into competition with 5G wireless, except we're 100 times faster in our baud rate. Okay.
Good. So this is where we are in terms of the technology at this point. Oops, it's like I've got a slide trying to do its own movements. We are, so 2020, we put up the test bed. We did it at C&M, as John mentioned. We also put it up at a test site in Albuquerque, the city of Albuquerque. This was to put together a whole network That device at the very, very top is our prototype 3. It's attached to a pole, and obviously we knew that wind and things were going to deal with, some of the alignment challenges and cause some of those challenges. So as John mentioned, prototype 4, we are correcting that in terms of being able to do automated alignment, self-alignment. This is where we're going with 2021 with the first product. We're in the design phase of that now. And then when we get out into 2023, we're looking to do a light pole, which essentially combines and creates a node for multiple links coming in. And John, just to quickly touch base on that light pole in terms of all the functionality we're looking at.
So what we believe will be at the light pole is multiple connections. We will be able to not only backhaul at 10 to 25 gigabits per second, where each pole talks to each other pole in a city and creates a meshed network. So if any link goes down, it just switches to the next fastest link. So that mesh network will supply multiple other networks, such as individual links to buildings and or homes that could be gigabit per second speeds. And also it supplies 4G or 5G cell phone units to be able to supply that area with communications. It also will have link into that backhaul. Basically, we're creating with that light pole. It will link in, or you can link in emergency radios, cameras, and other types of communications equipment.
So just to the attributes quickly, download speed, we are faster than other technology. We enable, 4G to be better than it is. We bring 5G up to the standard we're all expecting, and we work our way towards 6G, latency, as well as bandwidth. So the applications are numerous. We have focused on communication on the commercial side, but we have been noticed by various government agencies in terms of the application of our technology for more than just commercial communication. We have a phase 1, phase 2 grant from the DoD on a communications free space optical mesh network. We can't go into that on this particular call. We're happy to talk to you separately about that. And we've got a phase 1, as John mentioned, with the NSF. We have a number of good partners right now. We've raised our capital essentially from individuals, some angels, and from various institutions here in New Mexico, Plateau, Sacred Wind, both rural telecoms. Obviously, the Rainforest has been a great sponsor and a supporter of ours, as has C&M. And then we're working closely with Sandia and with Los Alamos. We've got the various awards and grants that are shown there. One thing I want to draw your attention to is in the era of COVID, the virtual aspect of dealing with what should have been in-person events. In the right-hand top corner, the 5G Open Innovation Lab. That was a very important event for us. And John, why don't you go into some of the touch points on that with the partners? Because I think you can explain it better than I can.
5G Open Innovation Labs, we were in the first cohort that's out of Seattle, and the partners in that lab are T-Mobile, Intel, Microsoft, Nokia, it goes on and on and on, all the giants. We were introduced to all of their groups of CTOs and individuals. It was slightly difficult in the virtual environment we were seeing, but we got a lot of interest out of that, and we got a fantastic recommendation from the partners in that lab for our funding effort that we now are about to open tomorrow publicly. So had some great discussions in the 5G Open Innovation Labs, and there's a heck of a lot of telecoms following us and very interested in what we're doing, including the largest telecom in Japan and the largest in Korea.
And we bring that up because we should have been sitting in T-Mobile's labs, able to walk down the hall and connect with people instead of that, we had multiple Zooms where John was in front of a room full of CTOs across all those big corporates. And now we're starting to see with the COVID, with that pandemic issue and the vaccines, all that kind of stress coming down, that they are ramping back up. And so we expect with what we're doing now in our fundraising effort that we'll see that. So the business plan, spend plan, move from the current prototype into a prototype 4, minimally viable product, move that into our first product to market, start ramping up sales, and then move into the smart pole. That 2022 ramping up sales, we just launched information broadcast out to about 4,000 plus ISPs that are part of the WISP organization, the Wireless Internet Service Provider Organization here in the United States. And we're starting to get, we've been marketing them for several years. Now we've got the demonstration and the proof of concept, we're moving forward into the next minimally viable product. That traction is really starting to take hold because we can start to put in front of them a timeline for giving them demonstration units. So where are we in terms of our value? We started with friends and family raised back in March of 2017 at about 30 cents a share. We then did a seed A raise, 2.4 million, all with individuals, the rural telecoms, CNM, UNM. We then went on and did a seed B raise. Each of these increasing the share price. We raised 1.2 million. We went from 30 cents on the friends and the family to $1 a share on the seed A to $1.25 on the seed B. And we are now out on WeFunder in the private sale, so invitation only. And as John mentioned, it's going to go public starting tomorrow. We've raised that to $2 a share. There is the early bird discount at $1.50. I'm going to put the link to WeFunder in. Why WeFunder? It is an incredible opportunity for us to reach grassroots level. As you guys probably know, regulation crowdfunding allows us to go out to non-accredited investors. The minimum investment number is $100, and we were already over 80, 85, I think, investors that have come in because we haven't really launched the advertising campaign and the PR campaign. So it's essentially been through a journal article last week. I'd say about 95 of those, 95% of that is coming out of Albuquerque and other parts of New Mexico. But we're now starting to see with what we launched over the weekend with the 4,000 plus ISP that they're starting to come in as well. So we're getting Ohio, we're getting Illinois, we're getting Washington State. So we're starting to get that kind of traction coming into it.
Let's mention, Mathis, quickly that WeFunder will give us operating funds, and while we organize a Series A VC round that will be over $10 million, we have a number of VCs that are following us and will be part of that. So that will turn out production. Thank you.
So that's the jumping off point. And I see David has popped back up, so he's about ready to tell us it's time for question and answer period. Here's the team. And David, yes, go ahead.
No, this is great. Thank you guys. And thanks for sharing the link to the site too. It's a great approach. We just had Drew Tulchin from the Angels talking a little bit about his crowdfunding last week. His experience with that, and Meow Wolf, it's a really great approach. Good to hear that New Mexicans are getting into that.
I'll just make one reference just on that, Dave, is that there are, Meow Wolf did a WeFunder back in 2017, and then a year or so more later when IPO, Soulstar is still in the WeFunder crowdfunding. They're about a 1.4 million. So we've got a couple of local companies in addition to Drew's that have hit that site. We're very excited about what it can do to bring in the every person on the street investor. But it is a launching point for venture capital.
Yeah, that's great. Speaking of venture capital, let's turn it back over to our sharks here.
Well, thanks for sharing so much with us. This is Frank. What wavelength are you using, and are all the parts coming from Sandia still right now, or
Negative. So we're using around the one micron. We're at 980 for one wavelength. We've designed 3 other wavelengths at 940, 1020, and 1060. And those wafers have been grown. They're in our possession. We will be processing our development at CINT, Center for Integrated Nanotechnologies. However, the chips we're using right now were produced in Torrance, California, at a foundry. A commercial foundry, and those have been produced. They're, I'd say, TRL level 6 to 7.
So they're VCSELs. They're VCSELs, not.
It's called a VCSELA. It's an actual VCSEL array, but the
Sure,
architecture,
sure.
yeah, the architecture is different than a normal VCSEL. It's patented, and it allows us to get as much speed as we want with as many VCSELs on that chip as we can put on there.
And are you doing anything in space? I mean, one of the challenges, there have been a number of groups over the years that have worked on here, on terrestrial things, and goodness, there's weather, there's birds, there's all sorts of things that seem to have been challenges. But I think there's been a lot of uptake of this type of links in space, right?
Well, yes, and we've solved a number of the free space optical problems in the past. So coherent lasers used to be very good at sending high speed information, but they would need a big mechanical gimbal to align that system and keep it aligned. We have solved that with this new non-mechanical beam steering in the NSF group. And then secondly, we've also brought that laser costs down, which they're typically using fiber lasers that cost thousands of dollars, and our chip virtually costs $1 in production, and we have incredible amounts of power and speed out of that. So a couple other things is we expand the beam with this. Since we have so much power, we can expand the beam, so when it leaves the device, that's weather resilient at that point. So snow and rain and stuff that gets in it, it doesn't matter. In the nanoseconds that it gets from one unit to the other, a lot of light still gets through.